Now, I have set up my string. I've got the string attached to the mechanical vibrator. You can see the function generator, and there's a little pulley, and there's a mass hanging on at the end of the pulley, making tension in the string. So there's a little bit of tension in the string, and you should be able to see a standing wave. Now this is really, really close to the second harmonic or second mode of the string. We want to start out with the fundamental. Now this is pretty cool. You can kind of see the string moving, but it's a little fuzzy. So let's change the frequency. So let's concentrate a little bit on the frequency, you see, and the size. So I'm going to try and change the frequency and get a fundamental note on it. So let's try and do that. You can hear it, it's a little annoying. So it's 526. Oops. All right, so I'm going to try and move this. All right, it's a pretty low frequency. The thing is, with the thickness of the string, it's very close to the fundamental. I'm going to put a little bit more mass on the string, and then we're going to try and find our fundamental. We're going to probably have a better chance of finding it. All right, I'm very close. So what I'm doing now is I'm going down to the 10th place, and I am, let's see, I'll show you. Do you see how you have one, there's a node at the mechanical vibrator, an antinode in the middle, and a node at the end. So what I want is only one, or a half of a wavelength, one blob basically. So let's fine tune this. I'm going to move it over to the 10th place. I'm going to fine tune it to see if I can get the maximum amplitude on this. So it's going down, now it's going up. All right, that's pretty good. So let's just swing it around. To see, I have one segment. So what I have is a fundamental, the string actually is resonating at the fundamental frequency. So this particular frequency, and you may not be able to read it. Let me go a little bit closer so we can read these values. The frequency that we're at is 18.52. 18.52. So now the only other thing we have to do is measure the length of a segment. So I'm going to use this little tape measure. I'm going to put the end right there. It's going to be kind of hard to film this, but I'm going to set this up right here. So we're trying to measure the length on a line here. So I've got one end of this right to where this string is. So this is 1 meter, 1.1 meter. So let's go right up to where the string hits. 1.175. 1.175. This is where it hits. You've got a little bit of parallax error, but 1.175. So that's our measurement for the fundamental mode, the length. 1.175. So that's half of a wavelength. And that's the fundamental. So you could put length 0 down there, 1.175. So that's half of a wavelength. To get a full wavelength, you have to multiply that by 2. Okay, to get a full wavelength. So let's actually move up the frequency to the next mode. And to find the speed, of course, you multiply the frequency times the wavelength. So what's that? Approximately 2.2 times 18.52. You get an idea of the speed of the wave. And the speed shouldn't change. We're not changing the tension right now. And at the end, I'm going to actually measure the mass. I've put this brick right here so that the mechanical vibrator doesn't move. Because it's wiggling up and down, sometimes it'll move in the direction of the mass hanger because it feels a force, a tug in that direction. So what I'm not going to do is increase the frequency until I see 2 segments. So I'm going to go back here, and you'll see right away when I increase the frequency to 23, it doesn't look like anything's happening. So I'm going to go up until I see. Okay. So I'm really close to 2. Not exactly. Do you see how it's sort of is going wah, wah, wah? It's beating or pulsing. I want it not to do that, so I'm close. I'm going to go to the 10th place and move my frequency to where I can get it. Nope. See that? It's getting steadier. Oh, now I've gone off of it. So I'm just moving the frequency knob until I get. All right. Do you see how now it's nice and steady? See that? So now there's 2 segments. I'm going to go and we're going to write down what the frequency is. So you can see the frequency is 37 point for the second harmonic. So we do the first harmonic as a fundamental, it's 1 segment. 2 segments is a second harmonic or the first overtone. So 37.020 hertz. So again, what is the precision? It's plus or minus 0.001 hertz. So it's 37.020 plus or minus 0.020. And what is the length? Now, length of 1 segment now, we go from node to node, so we're going to do half the measurement, but I'm going to measure it anyway, just like I did before. Now I have the measure. So this is less than a meter. Let's see if I can get it a little more clear. All righty, that's better. 58 point. What does it look like to you? This is actually a good view because you can see the, you won't have parallax error in here. 58 point, it looks like 58.5, right? So 58.5 centimeters, that's 0.585 meters. So again, remember, that's half of the wavelength. Take 0.585 multiplied by 2 to get the wavelength. You can see the columns there that you put this down in. Then the speed is simply the frequency, 37.02, times the wavelength. And it should be really similar to the velocity you calculated in the first harmonic. Remember, the speed only depends on the tension of the string and the linear mass density. We're not changing the string, we're not stretching it. It's basically the same mass per unit length. And we're not putting more mass on the end. So the tension remains the same.